I want to welcome you all to this lecture. It will be given by Dr. Marlene Zuk, who I'll introduce in just a moment. Before I do that, there are a couple of things I would like to do, a little homework for you. In the programs that you picked up, inside there is a little questionnaire. We scientists like data. We would like to know what we're doing right and what we're doing wrong and what we can do better. So if you will take a moment, please, to fill that out and leave it out in the front, I would really appreciate that very much. The second thing I want to do is to point out that one of the purposes of having these lectures is to engage the teachers of our kids. We have a number of teachers from the local area who are attending these lectures, and I would like to recognize them as we did 2 weeks ago. The teachers play such a vital role in the lives of our kids, and we can't, as my mother told me many times, say thank you enough. So thank you very much to the teachers. Would y'all please stand and let everybody recognize you? Thank you all so much. Now, I want to just share a little something with you. You really can't pass it around, I'm afraid. But I have a couple of books here that were brought by Dan Aldrich, who is our Vice Chancellor for University Advancement. They're loaned to us by John and Carol Fiacco, who are UCR alumni. This book that I have right here is entitled Insectivorous Plants by one Charles Darwin. And I have a 2-volume set that is absolutely gorgeous of the second edition of Darwin's Origin of Species. These are absolutely spectacular books, and I wish I could just sort of pass them around. I hope you'll understand I just can't do that because I think John and Carol would like to have them back in pretty close to the same condition that they got here. So if you would like to come up and look at them afterwards, I'd be happy to stick around a little while, let people take a look at them. So, as you all probably know, this is the 200th anniversary of Charles Darwin, which is one of the reasons why we thought this might be an interesting topic for these lectures. Now to the business of introducing our speaker for tonight, Professor Marlene Zuk, who's Professor of Biology here at UC Riverside. Marlene was a student at UC Santa Barbara, received her bachelor's degree in biology in 1977. She received her PhD from University of Michigan in 1986. She came to Riverside as an assistant professor in 1989, rising through the ranks to full professor in 1998. In 2005, she assumed a very important administrative role, becoming the Associate Vice Provost for Faculty Equity and Diversity here at UCR. Marlene has a large number of awards and honors. I'm not going to go through them all right now. I just wanted to highlight a few. In 1999, she was elected a Fellow of the American Association for the Advancement of Science. 1992 to 97, she was a recipient of a National Science Foundation Young Investigator Award. As I was looking through her resume, it was really very interesting reading. She's published somewhere in the neighborhood of about a gazillion papers with her colleagues. That's a very precise number, I know. But she also has a habit of writing interesting articles for the lay press. Her area is not that close to mine, so I don't read the original literature. But I became aware of Marlene actually before I came here as dean last summer, when I saw articles that she had written and were published in the New York Times. In 2008, in April, she wrote an article entitled "The Great Pox's Greatest Feat, Staying Alive." She wrote an article that was published in the New York Times again in January of this year, entitled "The Evolutionary Search for Our Perfect Past." reading the titles of her talks, her lectures, her books, book chapters, her original research publications, it's very clear that Marlene Zuk is a person who thinks very deeply about a wide range of topics. We're fortunate to have Marlene at UCR. We're fortunate to have her as our speaker here tonight. So Marlene Zuk.
All right. So as Tom said, I'm interested in writing for the general public, and my last book was called, which you can see the cover of here, is called Riddled with Life, and I tell people that it's a happy book about disease. And I think that, we really need a happy book about disease, in part because we tend to take this very dire view of parasites and pathogens. And of course, we use a lot of sort of war imagery, and we talk as if we're fighting a campaign and so forth. We're fighting the invaders. We're using drugs as if they're magic bullets. We talk about don't touch that. That it might carry something that would be dangerous. And we've got a lot of very negative and very warlike imagery about this, and that's sort of seen, of course, in popular books about disease. I sometimes tell people that my book's a counter to all of the what I refer to as the Ebola's coming, we're all going to die books. And you know what I mean. I mean, some of those books are very interesting, and I not to downplay the importance of Ebola. But seriously, there is a little bit of hyperbole here. So for instance, in a book called Secret Agents, so see, here's that war thing again, The Menace of Emerging Infections, Madeline Drexler said that the most ceaselessly creative bioterrorist is still Mother Nature. And in Laurie Garrett's The Coming Plague, which was published some years ago, the microbes are our predators and they will be victorious if we Homo sapiens do not learn how to live in a rational global village that affords the microbes few opportunities. So there's this idea that we're all supposed to be, kind of waiting with our weapons for the diseases to come after us, and then we're going to fight them and hopefully emerge victorious. But, and so the conclusion from this, of course, is that if we could eliminate disease from our lives, and if we never got sick, that life would be absolute paradise. But what I want to suggest to you is that you stop that for a minute, and instead, if you didn't think about disease that way, you thought about it not as our enemy, or at least not as only our enemy, but as more than that. What if parasites and disease are a part of life that we can think of as being with us from the very beginning? And it's not necessarily that being sick is good, or that diseases are wonderful, but maybe parasites and pathogens are a force that is just something that we've always had, like, for instance, gravity. I mean, think about it. Gravity is not always good. It makes our skin and other body parts sag over time. If you fall, your bones break because of gravity. Things in your house, if they fall, they break. A weightless environment, wouldn't have any of those problems in it. And so, you wouldn't have to worry about things sagging or breaking. But we know, of course, that gravity is something that our bodies evolved with. And so you can't remove it. Astronauts know that they have all kinds of ill effects if they spend time in a weightless environment. Its consequences may not all be wonderful, but gravity's what we're used to. Disease, okay, is not as benignly neutral as gravity, but it's still been a part of our lives ever since there have been people, ever since there have been living things. And so what if you thought about disease not so much as a good thing, but just as part of your family? You don't choose your family, and they're not sometimes the people that you would always want to be with. But at the same time, our lives are unimaginable without them. And for better or worse, they've made us who we are. Some people, have better luck or maybe less dysfunctional families, and some have worse, but nobody grows up without the influence of their ancestors, large and small. So disease isn't just sort of all around us, it's normal, it's natural, and it's even, I'm going to argue to you tonight, essential. So what I want to try and tell you is about how some of the ways are that illness, because we've evolved with our parasites and pathogens, because we've evolved with diseases, we couldn't be who we are without them. So I'm certainly not the first person to suggest that we could have an evolutionary approach to the study of medicine or to the study of diseases. Randy Nesse and George Williams wrote a book called Why We Get Sick, introducing what they refer to as Darwinian medicine, and lots of other people have suggested that if we take an evolutionary approach, we can have a new perspective on health and disease. And the idea is that if you look at disease as a relationship, if you think about parasites as organisms that co-evolve with their hosts, then it gives you a new kind of insight into what you think you can do about disease and what disease is likely to do to you. Now, a precept of Darwinian medicine or evolutionary medicine, it's called both, is to think about the ways our bodies have evolved over time. And so the idea, like I said, is that there's this evolutionary relationship between a host and parasite. But there's also another precept which suggests that there's often a mismatch between the ancestral environment in which we've evolved and the current one in which we're living. And that mismatch can sometimes cause various kinds of ailments. And there's lots of examples of this. People suggest that because we're now living in an environment where we have lots of refined foods, where we have easy access to sugar and fat and all those other things that taste great but are not good for us, that this has led to an epidemic of obesity and so forth, and that a lot of our problems are because we're living in a new environment with our old genes. And I think that's true to a certain extent, but before I go much further, I want to put a little cautionary note into this and talk a little bit about something that I don't think Darwinian medicine is telling us. Now, some people take this idea of a mismatch a little further and suggest that because presumably our ancestors evolved eating unprocessed foods, since there weren't French fries and Mars bars and stuff around millions of years ago, that we should in fact stick to those unprocessed foods now, and we should be eating what sometimes people refer to as a caveman diet or a Stone Age diet, and there's various manifestations of this, and you can find lots of stuff about this on the internet. USA Weekend Magazine had a feature on this a few years ago saying that your body craves nutrients that cavemen ate, and so we'd all be better off if we ate this diet from many hundreds of thousands of years ago. And I think that there's sort of this attitude of resignation that goes with it, this idea that, oh, well, no wonder we're all in the fix we're in health-wise because, we can't help it. Our environment just evolved away from us, and so there's nothing we can do. But what I'd like to suggest is that, well, we're really not doomed to ill health, and that, in fact, sometimes evolution can act much more quickly to take care of that mismatch between our environment and our bodies. And so the example I want to use is one that probably some of you are familiar with, which has to do with lactose tolerance. Now, as you know, most mammals lose the ability to digest milk after they stop nursing from their mothers. And so they can no longer break down the sugars that milk contains, and they have digestive difficulties. That's also true of many humans. I'd wager that there's at least some people in this room that are lactose intolerant. But interestingly, that's not true of all humans. And the reason it's not true of all humans is evolution. Some very interesting recent work has shown that lactase, the ability to, so if you can break down milk sugar, then you possess an enzyme called lactase. The persistence of that enzyme is much more common among people in Central and Northern Europe and their descendants than from people in Africa and Asia. Now, this isn't fixed. It's not, so don't be, coming up to me saying, my ancestors came from Northern Europe, and I'm like, yeah, I know, it's not 100%. But generally speaking, this is where lactose tolerance seems to be occurring. And those parts of the world are exactly where people started, tens of thousands of years ago, started to domesticate animals, and more recently started to domesticate cattle. The idea now is that being able to digest milk past weaning is very advantageous for humans if they're in a society where, for instance, nutrition or potentially even water is in short supply. It provides a really good source of nutrients. And so a study that was done a few years ago and published in Nature Genetics finds that, in fact, if you look at evidence for where cattle were domesticated and the distribution of the genes that are responsible for domestication in cattle, that's exactly coincident with the genes in humans for being able to digest milk. What's happened is that we and cattle evolved together. So the moral of the story here is that this mismatch may not be uniformly true. This evolution, which has happened in humans in a very short time, the domestication of cattle is thought to have occurred about 7 to 9,000 years ago. Evolution can still happen, and we can indeed adapt to a new environment. Okay. So, and certainly I'm not suggesting that that means we're all going to be able to adapt to a diet of, Big Macs and, soda and so forth, and that we can just sit back and wait for that to happen, and it'll all happen in the next 5 minutes or even the next 50 years. But the point is that certainly we're very capable of adapting to our environment in what used to be thought of as a far too short time for that to happen. Okay, so that kind of cautionary tale aside, what about diseases, real diseases, and their relationship to our potential mismatch with our environment? I'm sure that, I'm sure that all of you have seen the really scary statistics about type 2 diabetes, which used to be called adult onset diabetes, and how it's skyrocketing all over the world. As of 2007, the diabetes accounted for more than $174 billion of healthcare costs annually in the United States alone, which is about 15% of all of our the costs that we're spending on all diseases combined. And the number of cases worldwide is huge. Every estimate is people always say that every estimate is also doubtless an underestimate, because for every case that's diagnosed in the first world, there's doubtless many more that are undiagnosed, particularly in the third world. And indeed, the third world is where diabetes rates are really increasing. So in non-European, in people of non-European descent, and in places, say in the Pacific and in a lot of Native American communities, rates of diabetes are extraordinarily high. But the real puzzle, and Jared Diamond published a paper on this in 2003, is not just why the disease is becoming so prevalent, but why it isn't increasing quickly in those of European descent. Now, diabetes does have a genetic basis. As you all know, I'm sure, obesity and lack of exercise can make it more likely that those people with the genes that make them likely to get diabetes are actually going to have the disease. So with an appropriate diet, if you have the genes, you may never get the disease at all through your lifetime. So why are some groups showing this rapid increase in prevalence of diabetes and others not? Well, the current thinking for that's an evolutionary explanation for the prevalence of diabetes is that it is something that's called the Thrifty genes hypothesis. And James Neal from the University of Michigan came up with this some years ago. And the idea is that if you have genes that allow you to efficiently utilize sugar and store fat really well, and your food supply is very up and down, so you've got kind of a feast or famine sort of lifestyle, then when those famines occur, you're going to be in really good shape. You are going to be someone that can make it through the famine to the next time when food is readily available. The problem is that if food is always readily available and you're always eating as much or maybe a little more than you actually need, then you have this predilection to very high sugar levels and to inappropriate response to insulin, and then you can develop diabetes. Well, okay, so where are those genes going to be most prevalent? The idea, and so why aren't we seeing this in Europe? The idea is that famines did indeed used to be common in Europe. I mean, our historical evidence tells us that. But according to Diamond and some other researchers, they largely stopped by, depending on where in Europe you're talking about, anywhere between 1650 and 1900. And so during that time, scientists are hypothesizing, there was already natural selection occurring on on Europeans to get rid of those folks that got diabetes, developed terrible disease from it, and died. And so they didn't pass on their genes as much as people who didn't have those thrifty genes and didn't have this ability to hang on to fat and sugar for those lean times. So their epidemic of disease was gradual, and Europeans passed through it. Interestingly, and in support of that idea, diabetes rates are higher among Australians, among we Americans of European descent, than among the Europeans that were our ancestors. And Diamond hypothesizes that that's because those immigrants, the people that left Europe for America or for Australia, tended to be of a lower social status. They had a more recent history of having famine, and that selection to, do well by your sugar and fat was not removed from those populations as quickly. So the idea is that diabetes is showing itself in part because of our evolutionary relationship with our environment over time. And you can see this even more clearly in non-human animals. If you look at our domestic animals, we've domesticated different kinds of animals for different things, of course. Cows and pigs, which we eat, we selected for the ability to accumulate fat quickly. So we want cows and pigs to be able to gain a lot of weight and grow fast so we can eventually slaughter them for food. Dogs and cats, on the other hand, are not selected to be able to gain weight quickly with no ill effects. They're hunters. They're supposed to be able to get by on small amounts of food and to help us out by doing things other than serving as food sources for us. And it turns out that indeed, as some of you probably already know, cows and pigs don't get diabetes. For all the other problems that people farming cattle and taking care of pigs have, they don't get diabetic pigs. Dogs and cats, however, can indeed get diabetes, especially when you tend to indulge your pet with all kinds of table scraps and so forth. And so modern pet dogs and cats are susceptible to diabetes, which again reflects their evolutionary heritage as opposed to cows and pigs. Now, interestingly, there are some pigs that can get diabetes. There were domestic pigs introduced to Ossabaw Island, which is a small island off the coast of Georgia in southern United States. And they were feral and just lived free, kind of happy pig lives in the forest for about 500 years. Some people decided they wanted to bring them back into captivity and, have them just, actually, I don't know why they did that. They just thought it was kind of a cool idea. I guess they're kind of cute. That is an actual Ossabaw Island pig, incidentally. When they were brought back into captivity and reared as if they were domestic pigs and fed all the way you would feed a domestic pig that you're raising for pork, indeed, they develop hyperglycemia and a tendency to diabetes. So this evolutionary relationship with our environment can affect us and affect our diseases in ways we might not have anticipated. Now, this kind of mismatch with our environment, incidentally, also can happen on a much smaller scale. So I've been talking about it with regard to thousands and thousands of years, but there's also what evolutionary biologists refer to as developmental plasticity, which means that your early environment when you're growing up then shapes the way you look or the way you feel as an adult. And so lots of biologists are real familiar with this. These are Daphne or water fleas, and they're very small, but they're eaten by fish and other predators, and if they grow up in an environment that has predators in it, they have that spine on the top of their heads, as it were, and the spine helps to deter the predators. But if the exact same genetic, an individual with the exact same genes grows up in a pond without predators, then it grows up without the spines. And so it's like you're fine-tuning things to the environment depending on what's around you, and being able to do that is, of course, evolutionarily advantageous. Now, those things also seem to be able to occur in humans. People are starting to do a lot of really, really cool work with what happens to the maternal environment that fetuses experience before they're born, and then how that interacts with the environment that they experience after they're born. If a mother is experiencing a food shortage, a famine, she's more likely to have a baby with a small birth weight. And that's advantageous, obviously, because having a baby with a small birth weight will need less food. You know, that means the baby's going to need less food. If there's a famine on, that's probably, you know, a good thing. The problem is, though, that if after the baby's born, food is readily available, having a low birth weight also gives you higher insulin resistance, and it means that if food is plentiful, it can lead to diabetes. So this sort of push and pull between the environment and the way your genes express themselves is another way that evolution influences the kind of diseases that you can get. Now, this sort of plasticity isn't incompatible with the Thrifty genotype hypothesis. I'm just looking at things at a different kind of scale. I mean, usually, of course, your fetal environment predicts your adult environment, so it's a good thing. It's just that now we're running into problems because frequently the environment changes rapidly, and children are being given food sources that their fetal environment did not lead them to expect. It also works in things other than food. Blood pressure is one of those things that shows the same kind of predictive adaptive response. Now, as you know, you lose a lot of salt when you sweat, and so in a hot environment, you can imagine that being able to hang on to salt, which can then lead to high blood pressure, could actually be advantageous. So if, you know, the choice is losing too much salt and, you know, or perhaps having a tendency to have high blood pressure, if the environment is extremely hot and you're sweating a great deal, hanging on to that salt's really adaptive. But again, it can lead to sort of repercussions later on. And this can be extraordinarily fine-tuned. I love this study. So there's nearly 4,000 British women that were just surveyed. They were born between 1919 and 1940. And then some researchers just looked at the relationship between the highest summer temperature during the first year of their lives, which you can get from weather records, and their blood pressure when they're at age 60 to 79. And it turns out that the higher the temperature when they were in their first year of life, the higher their blood pressure was 60 to 79 years later, which I think is just incredible. And the idea is that if you're hanging on to that salt, for instance, things like infant diarrhea are more common in hot weather, and so hanging on to that salt is advantageous, but you pay the price later on. Okay, well now I want to shift back to this idea about parasites as potentially being, if not our friends, at least potentially members of our family. And so, you know, here we are back in this war imagery, and people take this not just in terms of fighting Ebola or, you know, fighting diseases on sort of a wider scale, but on fighting the parasites that lie within us. And I don't know if any of you have run across this big fad recently for you know, colon cleansing, which, you know, really, in my opinion, you know, you see the ads for this and it gives me way more information than I really want to have about the way a lot of people's bodies are. But the argument is often that you've got all of these parasites inside of you, and so if you don't, you know, use these things, which, so I'm not going to go into the details, like there's way too much information. So if you don't use these products in the way in which the people are trying to get you to use them, then you're going to have all these parasites, and this is just from one of the websites for this Innovative Health Solutions, which says that, you know, there's parasite inside you all the time. In war, one of the best winning strategies is to attack, hold your new position, and then bring up reinforcements. We employ a three-pronged strategy, we assume that's not literal, in a major war against deadly organisms that sweep through the body undetected, parasites. And so, you know, this is a huge industry. I mean, if you ever have a spare moment and you're surfing the net, just check out cleansing or parasite cleansing, and again, like I said, too much information. But the point is that there's this widespread idea that what we need to do is get rid of every single parasite or pathogen or microbe that is possibly invading or inside of our bodies. The problem is that that's actually not a very good idea. And it's not a very good idea in part because what we're starting to see is an increase, not just in diabetes, but in some other diseases that have often been referred to as diseases of the advantaged. And I'm talking about things like allergies, asthma, a lot of autoimmune disorders. Asthma alone increased 75% between 1980 and 1994. It's still increasing. I actually meant to update that and didn't, but it is still on the rise. Asthma is much more common in industrialized countries than it is in less developed parts of the world. And even within industrialized countries, it's less common in rural environments, in families that have more children, in families that have pets, which is counterintuitive, I know, to a lot of folks, or to families that have sort of farm animals around. So we've got a lower frequency of asthma in those situations. And a lot of scientists started wondering what was going on. And people thought, well, okay, in industrialized countries, particularly in non-rural environments, maybe it's air pollution. We've got a lot of stuff in the air that maybe is triggering asthma and allergies and so forth. It turns out that's not the case. Absolutely, and again, I'm sure some of you here know this, air pollution and other contaminants can trigger an allergy attack or asthma attack once you've already got allergies or asthma. But pollution is not the cause of this. And some very interesting work started to establish at least an intriguing idea about why we're seeing this huge increase in the diseases of the advantaged quite a few years ago. A medical researcher named Erika von Mutius compared asthma and allergy rates in the former East and West Germany, and she looked very shortly after reunification. And she had thought, as I think we all would have just a priori, that because pollution was higher, in general levels of medical care were worse, and there were people, standards of living were lower in the former East Germany, that they would have higher rates of asthma and allergies. Exactly the reverse turned out to be the case. The rates were higher in the West than they had been in the East. And she and some other researchers have formulated what they refer to as the hygiene hypothesis. And the idea here is that if your environment lacks immune stimuli, it lacks the normal sorts of things that we're all used to, dirt, microorganisms, even indeed disease-causing, bacteria and viruses, if you don't have those things, then you increase the risk of developing asthma, allergies, eczema is another example of one of these diseases, and so forth. The problem seems to be that your immune system doesn't get regulated if it's not exposed to things like endotoxin. And endotoxin is a component of bacterial cell walls, and it seems to be particularly important in stimulating the immune response. It's also particularly prevalent in rural environments, and it's also, people always get grossed out by this, but where there's fecal material from animals that can get aerosolized and is sort of in the air, you tend to have higher levels of endotoxin, and that's a good thing. People don't tend to like that, as you can probably tell, I'm kind of on the anti-germaphobe side here, and I'm always amazed at the number of new, sanitizing products that people will come up with. In my book, I mentioned there's one ad again that what do they try? Oh, I know, it's a germ-resistant keyboard for your computer, because it says that, and it gives you this factoid that you're supposed to be really grossed out by, that it says that the average computer keyboard has more microbes on it than the average toilet, which is supposed to horrify you. But see, I'm kind of a glass half full sort of person, and I looked at that and I thought, wow, I couldn't believe that so this suggests that the average toilet is actually pretty clean, right? That was kind of, I was happy about that. I thought that was kind of nice. And then the other thing I started worrying, my inner statistician started thinking, well, but, so how do you get the average toilet? Really? So, what's an average toilet? So clearly the whole thing was kind of lost on me, but I'm sure you realize that there's tons of these products coming out all the time. I have somewhere written down that, how many hundreds of them were introduced, per year and so forth. But the problem is that this turns out to at least potentially do more harm than good. If you have more endotoxin levels in bedding, this was associated with lower levels of asthma in a study of 812 European children. And so this also applies, like I said, not just to endotoxin, but to just viruses and bacteria. People who had a positive tuberculosis test, which means that they've been exposed to the tuberculosis bacteria, had fewer allergies. Again, this is a big survey of 23 European countries. Children in Gabon in Africa that had signs of schistosomiasis in their urine, which is a very bad disease, also had less sensitivity to dust mites. Now this brings up a point that I don't want to be telling you. I'm not suggesting that, oh, disease is wonderful and we should all be terribly sick. And I certainly don't think that. I'm just trying to get you to understand that you don't remove all of these stimulants that we have evolved with without getting some repercussions. And some of those repercussions are not great. So the idea behind the hygiene hypothesis is that your immune system, as you know, has a number of different cells that help mount a response that get rid of illnesses when you're exposed to them. And the idea is that there's two arms of the immune system, two kinds of what are called T helper cells, which are kind of white blood cell, Th1 and Th2. And if you're in a family where there's a lot of siblings, you tend to get infected a lot because, as you know, kids are always bringing stuff home. That stimulates the Th1 arm of things, and you tend to develop fewer allergies. On the other hand, an only child who is surrounded by parents that clean every surface that the child ever touches and boil things before they let the kid put it in their mouth and so forth, then you end up not getting that side of your immune system stimulated. It doesn't regulate Th2, and Th2 tends to be more likely to occur, tends to be more likely to go sort of haywire when you're exposed to harmless things like pollen or peanuts. And so this idea that over-hygiene of our environments has led to these diseases of the advantaged is starting to catch on, not just with allergies and asthma, although the other point here is that, so I don't know how many of you have kids that are either in daycare or even just in elementary school, but a faint hope, I know it's a real pain when they come home sniffling and sneezing and with all kinds of bugs, but the number of colds that a small child has is directly related. The more colds they have, the less likely they are to get asthma and allergies as they get older. So I don't know if that helps or not, but you can kind of cling to that. It doesn't help, yeah, I can tell nobody's really enthused. So I want to talk about another so-called disease of the advantaged here, which is Crohn's disease, which is an intestinal disorder. It's an inflammation of the digestive tract. It causes pain. In effect, what's happening is that people are developing an immune response to their own intestinal lining. It's a dreadful disease. I don't know if any of you have it or know someone who has it. It causes a lot of complications. People have trouble, obviously, getting enough nutrients. They often need surgery. They'll go in and out of having bad problems with it and so forth. Now, Crohn's disease, like allergies and asthma, is also more common in industrialized countries. It's also more common at higher latitudes. So the further you get away from the equator into colder climates, the more common it is. And it's also risen since the 1930s. And I'm going to read you a passage of, so it's now something that used to be extremely uncommon. Joel Weinstock, who's a gastroenterologist at Tufts University in Boston, says, once this was a disease that people spoke of in terms of 1 in 50,000, then 1 in 10,000, then 1 in 5,000, and now 1 in 250 people. Crohn's disease is a disease that is common, not rare. It also, when it was first starting to be recognized in the 1930s, it started to be recognized disproportionately among Jews that were living in urban areas, particularly in New York and in the eastern part of North America. Now, Weinstock started to wonder if the problem wasn't so much something that people in areas where Crohn's is prevalent had, like, people were wondering, is it some environmental contaminant they're exposed to, is there some, other problem? But maybe it was something they'd lost. Specifically, he points out that people in modern urban areas don't have the intestinal worms that they used to have as little as 50 or 70 years ago. It used to be that even in, places in the West with good, hygiene and good medical care, that intestinal parasites, not really severe cases, but occasional cases of worms, were fairly common. In the 1940s, 1 out of 6 Americans showed exposure to trichinella, which is a parasite that you can get from eating undercooked pork. But by the 1960s, this proportion was less than 5%, and less than 0.5% of people had indications of a recent infection. What's more, starting in the 20th century, people, actually started giving themselves drugs and taking medicine to get rid of worms, which is something really new in our evolutionary history. And so what Weinstock says is that if you simply follow inflammatory bowel disease around the world, wherever there's deworming, you are seeing a rapid rise in inflammatory bowel disease frequency. Again, what seems to be happening is that nobody's saying that it's great to have worms, but what they do, especially in children, is stimulate Th2 response, which then helps regulate the Th1 response, and you end up with a sort of modulated immune system. A malfunctioning Th1 response is characteristic of Crohn's disease. Now, so some of you can probably see where this is going. What Weinstock suggested is that maybe for people who are suffering from Crohn's disease, we can cure their symptoms by giving them worms. Now, what he wanted to do is not, of course, give them human parasites, because that has a lot of other side effects. But he suggested that we could give people pig whipworms as a treatment. Now, pig whipworms are obviously found in pigs, but they aren't able to establish themselves in humans. However, they stimulate the same kind of immune response in the intestines that a normal human parasite would. And so what Weinstock suggests, so there's a picture of the worms in the side of somebody's intestine. I think they look kind of perky. Like they're actually, he's got a close-up. I can't remember if I have it in another slide here. I think it looks kind of cute. But anyway, so what they can do is they can give people worm eggs. So they don't give people actual like big wriggling. It's not like giving people like earthworms, and you're eating them like that. Instead, what they're doing is they're giving people the egg, worm eggs. So they're microscopic. You can't see them in a solution of Gatorade, and then you repeat the dose every 3 weeks. And so he did a double-blind study in 2004, and there's been another study since then. And 3/4 of the patients in that initial study showed remission of their symptoms, like complete remission of their symptoms after 6 months. And so, oh yeah, that's the one. Don't you think this one looks perky? Don't you think it's kind of, I like that. Like there it is. And so the idea is that you have to repeat the dose because the worms don't stay there. They're flushed out because they can't establish themselves in the human intestine, but they stimulate the same kind of immune response. And so, so I was communicating with Weinstock about this because I was really intrigued, and I asked him actually whether people would, like, God, do people really go for this? And he said that, oh yeah, that you have to understand that people with this disease have often been taking really horrific, treatments with really terrible side effects often for many years to almost no effect, and so they're really ready to try anything. A few worms seemed fine to them. Although it is true that, so this was in a great paper. Weinstock's actually pretty irreverent about this, as you can see. But there was these Canadian medical researchers said that we have to be careful because the individual patient's perception of helminth therapy and their adjustment to the concept would be a pivotal decision branch in any logarithm of potential treatment approaches to colitis. So, in other words, if people are really grossed out, they're not going to want to do this. But apparently that's not a problem. And so Weinstock, who I think he's kind of a worm enthusiast. He's sort of like a worm booster. And he says, these are both quotes from some of his emails to me, that people have what I consider an irrational fear of worms. Then he's got, so this last statement is, something that it's kind of like his shtick. It's his signature statement. He used it in one form or another in almost all of his emails or letters to me. He said, kind of like people have their little signature thing that they say. Well, this is his. Half the weight of your stool is living bacteria. What are a few worms, more or less? So, I'm not sure that's really words to live by, but, it's certainly, worth considering. And what I love about, you can tell, I think this is just great. And what I love about this is that without doing it intentionally, this is a very evolutionary response to disease because it recognizes that parasites, it's not that the parasites are good for us, it's that we evolved with them, and if we remove them to our peril. Okay, the final really short example I want to give you is one from the World Health Organization, which also did something unintentionally, I think, evolutionary, which is that, as you may know, so intestinal worms are a bad problem in school children in many parts of the developing world. And there have been a lot of efforts worldwide to try and deal with this, mostly by trying to take a subsection of kids, give them these very intensive drugs that will get rid of the infection entirely, and then see if that'll work. And then if that works, they would try and take it to a larger scale. That almost never works. And the worms come back because it's very difficult to maintain an environment in these parts of the world where there isn't reinfection. And so this new program called Partners for Parasite Control said, okay, look, we're never going to get rid of all the worms. All we want to do is reduce the intensity. We don't want kids, or well, ideally, sure, it'd be great if everybody had clean water and kids could have no worms. But instead, we're just going to try and reduce the dose so that it's at a level, or reduce the infection so that it's at a level where the kids are not experiencing really bad effects from it. And that instead seems to be much more successful as an approach to public health than to this sort of take no prisoners idea that is what we've often been doing. And so, like I said, I really like it because I think it's a more evolutionary approach to the way we live and work with diseases. So in conclusion, then, I hope I've shown you that an evolutionary approach is useful in understanding and I think even treating diseases. That parasites and pathogens are not always or only the enemy. That maybe if you won't take them to be your friend, at least you might think of them as part of your family. That disease is normal, and that if you try and remove all parasites, you try and make our world completely clean of all sorts of pathogens and challenges to our immune system, that too can have some unforeseen consequences. Thank you.
So we'll take a few questions.
Sure.
Are there questions? Is that Norm?
I can't see, so you're going to have to either yell or
Thanks for the great talk. On a recent NPR radio show, I heard some speculation about autism as an autoimmune disease. Any thoughts about parasites and autism?
Yeah, I heard that too, and I also actually read this, what I thought was a little bit alarming case of a woman who was trying to dose her autistic kid with literally with worms to try and see if she could do this. I think the problem with autism, like a lot of other disorders that are, the term comes not from knowing specifically what causes it, but because it's a wide spectrum disorder, is that something that works for one person or for one symptom is not going to work for lots of other people with lots of other symptoms. So the autism, my impression is that medical researchers, the jury is very much out on that one because there's clearly an interaction between genetic factors and some other environmental causes. So the autism one, I'm not willing to go there. I'm happy with the Crohn's disease.
Marlene here.
Is it on?
Yes.
Hi. My question, I just want to revert back to diabetes in your beginning of the speech there. I just want to know if there's any correlation between diabetes and the excretion of the thyroid, metabolism, and like if individuals who have not necessarily a hyperthyroid, but more excretions from their thyroid, if they're less prone to diabetes than as opposed to a person with a normal thyroid, and or somebody who doesn't excrete as much from their thyroid and its metabolic, processes.
Great question. I have no idea. Any doctors in the audience want to answer? I mean, I've never looked at it. I've always wanted to ask if there was a doctor in the audience.
Nowadays, all of us use that sanitizing hand spray. Is that a good thing or bad thing?
Oh yeah, so the hand sanitizers. So the hand sanitizers, the alcohol-based ones are great. What you don't want to use, well, two things. First of all, again, as you've probably gleaned, I'm not one of those people that thinks you should be washing your hands like 50 and 60 times a day. I mean, the usual, like if you're sick, after the bathroom and so forth. But so I'm actually not a maniac about doing that. The stuff that you use that is just physically removing the bacteria is terrific. Alcohol-based stuff is fine. You want to stay away from anything that's got antibiotics. I don't like antibacterial products. I think they're unnecessary, and they encourage people to use antibiotics in very irresponsible ways. So, I think that most of the stuff that's in the hand sanitizers is alcohol-based. Some of them are not, and actually there is a little bit of a question about resistance evolving for those. So I don't really think you need them. Most people have this thing about if your kids should be eating a lot of dirt and it stimulates their immune systems. I'm in favor of that one.
Please go ahead. You have the microphone.
Yes. Hi, Susan Heath. Currently, there's a controversy among young parents, especially the better educated ones, about the number of inoculations that doctors are giving babies. What is your theory about this? And it's more than just the autism factor.
Right, yeah. So, thank you. So I did not mean to give the impression that you should not be vaccinating your kids. Vaccines are a good thing. And vaccinating kids, so sometimes parents will say, oh, but if you vaccinate them, doesn't that prevent their immune systems from becoming robust? No, no, no. We're talking about vaccinating against very specific ailments that are way, way, way bad for you. So I'm definitely not an advocate of the don't vaccinate your kids because it will make their immune system stronger. Now, there are some questions, and I am totally not qualified to answer them, about whether the pacing of vaccinations for kids today is ideal, whether it can, engender, various problems in them and so forth. I'm not qualified to answer that one, but the idea that you shouldn't vaccinate your kids because it will be better for their immune systems is very, very flawed and dangerous. And we're already seeing, as I'm sure some of you know, some outbreaks of measles and other very, very preventable diseases in places where people should frankly know better.
Right here, Marlene.
Sure.
Well, it's nerve-wracking with the microphone. I really enjoy your talk, and it's funny because I have a lot of family in the medical field, and I've always been harassed because I bite my fingernails, and I really liked your the hygiene hypothesis, because I used to always tell people it makes me immune, and for whatever reason, I have never gotten colds, but I do have asthma. But honestly, I think it was really funny just to sort of hear that exposure.
I've never heard anything about fingernails in particular, but sure, go on. Yeah.
So my question to you is, how can you get the hygiene hypothesis to support my theory that biting my fingernails actually makes me more immune and better prepared?
We can only get it to support the hygiene hypothesis if you spend a lot of time grubbing in the dirt. Then that'll work. So get a lot of dirt under your nails, and then that'll work real well, which is good for other reasons.
Please pass. Hello.
Hi. I don't understand how this is evolutionary in the sense that if these are responses to present conditions, are these qualities that if I'm a relatively unsanitary person and I have a strong immune system, is that quality passed on to my progeny? And conversely, if I'm a clean person who takes all of the precautions to be a germaphobe, and so I have a weak immune system, is that passed on?
No, so the idea is that we all of us, evolved in an environment where it was completely impossible to keep ourselves free from parasites and pathogens. And so we evolved, and our immune systems evolved with things like intestinal worms, bacteria. I mean, our guts are already teeming with bacteria even when we're healthy. And so what we're doing now so if, 30,000 years ago, the most ardent germaphobe, whether, he or she was passing this on to their children or not, could not possibly keep their environment anywhere near as clean as we can keep our environments now. And so the argument with the hygiene hypothesis is that you're taking away something that evolutionarily your body is used to having. That, generation upon generation of not just humans, but every other organism on the planet evolved with all of these co-inhabitants, if you like that word a little better than parasites. So that's why it's evolutionary, that the reason we have this response is through many, many hundreds of thousands of years of a relationship with these other organisms living in and on and around us.
Yes, I was wondering, like, you see so much in marketing and on TV and the newspaper and advertising, Listerine kills germs. You go to the doctor and the first thing they prescribe to you is some kind of antibiotic or ointment for a cut or an abrasion or something like that. So it's, what you're trying to say is that all of this is wrong?
So again, not all of it is wrong, and I'm not suggesting that people should stop curing disease, okay? Curing disease is a good thing. Vaccination is a good thing. Diseases are not a good thing. But it is absolutely true, what the last thing you said, antibiotics are alarmingly overused in this country. I'm sure all of you have been hearing about this on the news. And again, this is evolution, that what's happened is that we have provided an evolutionary force to select for resistant bacteria, and it is having terribly scary consequences. There's, MRSA and all these other diseases that we now can't fight occur because of an evolutionary response. So, I'm not suggesting that people stop curing disease. I am suggesting they stop taking antibiotics for viral diseases, for which they can do no good, however. So, if you take away one thing, take that away. Stop asking your doctors for antibiotics if you have a cold or the flu. It won't do any good.
I just had a couple things to say. Growing up on a farm, I can definitely agree with, we ran around barefoot all the time.
Do you have allergies?
I don't have any allergies.
Yay.
I don't have asthma. All those good things. I've had ringworm, it's a farm thing. I don't know if anybody grew up on one, but, you're running around in the summer, it's hot, you get, whatever. But I think too, it's, if we got a cold, we just got over it and we just let it go. And we had family that lived down in the city in New Orleans, and they got sick all the time. We lived out on the farm and we were healthy all the time, so I think that supports your theory. But again too, I think just looking at the cattle and the pigs and things like that, you can definitely see the impact of hormones, things like that on the animals, the evolution of that. A lot of my family is lactose intolerant that live down in the city. I grew up drinking
whole milk.
I guess you're done. Wow.
I grew up drinking whole milk. I can still drink whole milk. No allergies to it or lactose intolerance. And then you guys just go to support your environment, parasites.
There is certainly some suggestion that that it's become kind of faddish for people to say that they're lactose intolerant, and I'm kind of staying out of that one. But there really are a lot of people who claim that they're lactose intolerant and really are not. So maybe one more, and then we should let these nice people go. I mean, I don't want to keep everybody here if they don't.
Yes, I have a question about the factor of genetic predisposition for allergies and asthma. My oldest daughter developed allergies, and she raised a goat for 4-H. We always had a dog from the time she was 2. We had a huge garden. She had her hands in the dirt. When she was 5 years old, she developed a severe reaction to cats after having stayed with a babysitter who had cats inside on the counters. And then 6 months later, Ruth was visiting her sister's godmother and just had this really bad reaction. She developed asthma at 12. She's now 37. She still has asthma. And when she developed that, she went to visit her friend's rabbits in the 4-H exhibit hall, and she came home and her eyes were swelled shut. She has allergies and asthma like my mother did, and I often feel that I passed it, although I don't have either of those. None of the other 3 children developed those allergies and the asthma. So, and they were all raised in the dirt in Oregon. So my question is...
I've got this really great mental image of your kids. Let me see.
So my question is, what is the genetic predisposition? How much does that weigh?
So there certainly is one, and one of the reasons that people, of course, that we haven't just knocked this, flat by now, and that we don't have an absolute cure, is that of course there's lots of things that interact. So you've got a great example of there can be lots of people with a genetic predisposition that if they're in the right environment, who knows, maybe if you'd raised your kids in a semi-sterile environment, your one daughter, rather than just having allergies to cats, would be so terribly allergic and asthmatic that she would be unable to survive, or something like that. So yeah, of course there's going to be variation in people and how their own genetic background interacts with their environment. That's one of the reasons that having these studies done on a broad scale is going to be useful. But I think the thing to remember is that it really is possible that you did it for your other children, and that for that one you did everything you could, but you just you just can't do everything for them.
Marlene, could we take one more question, please? The person back there with the microphone. Thank you.
As the father of an extremely allergic child, I made some research.
Don't blame yourself. It's okay.
Yeah, I don't. It seems that another sensible theory is that we have too much processed food. We're consuming too much processed food. What will be the evolutionary explanation for that?
So people have suggested that, certainly, that processed foods are a problem. That may well be, but that's a different source than this. So because that doesn't have to do with your interaction with living things in your environment that are going to stimulate your immune system. I have certainly heard that, but I think that's separate. And obviously the idea that giving people less processed food is probably a good idea is fairly innocuous.
Well, having been in Marlene's place myself, this is an extremely tiring thing that she's doing right now. I think we should give her a break. Thank you very much, Marlene.